Today, we're going to talk about how to do arithmetic with different bases. Doing arithmetic with different bases is just like doing arithmetic with base 10 in the sense of when we're talking about adding, needing to carry. So these two numbers are base 5. In base 5, the only digits that exist are 0, 1, 2, 3, 4. So if we add up some numbers and we get something that is bigger than 4, that's when we have to carry. Just like in our, I can't see it, huh?
Yeah.
Just like in our number system, when we add, if we add things and get something that's bigger than 9, that's when we have to carry. So if we're working in base 5, like the first example, if we get something that is bigger than 4, that's when we're going to have to carry it.
These are pretty simple.
Hmm?
These are really simple.
Adding and subtracting aren't too bad. Multiplying is a little bit harder. We're not going to divide. Dividing gets really pretty tricky.
Okay.
So, I mean, it's the same concept. I mean, think about like long division. Some people didn't mind long division so much. Some people really hated it. So it's kind of like long division, but in a number system that we're not really comfortable with. So if you already hate long division, then now doing it with a number system we're not familiar with is just not something I wanted to tackle. So, so when we add these up, we'll add them digit by digit the same way we would normally. But 2 plus 3 is 5, and 5 doesn't exist in base 5. So then it becomes a 1, 0. Okay? Just like we would count up in our number system, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, but we call it 10. So in base 5, we count up 1, 2, 3, 4, 1, 0. Okay? So now we add up 1, 4, and 2, that's a 6. So that would be a 1, 1. Because it's,
Whoa.
it's 7, so it would be a 1, 2. Thank you. Remember that arithmetic is not my gig, right? So be willing to correct me on that. And then 5 and 1 more is 6, so that would be a 1, 1. And then that's our final answer. We put that little base 5 down there so we know we're talking about a number system of 5s.
Oh, I'm confused here. Wouldn't you have, like, for the 2 or whatever, wouldn't that be like a 5 and then a 2 up top? Or I don't understand.
5 does not exist in base 5.
Wouldn't it be like a 4 with a 3 up top?
Remember when we count in a base 5 system, we would say like 0, 1, 2, 3, 4, but then we run out of digits. So just like we hit 9 and we have to start counting 10, same thing here.
Oh,
So we count 10, 11, 12, but we don't call them that, 13, 14, and then we run out because there isn't such thing as a 5, so then it would become 2, 0.
Oh, so you put like a 0 and then like the one on top. Oh, okay. Okay, I get it now.
So to add in binary, the only numbers that exist in binary are 1s and 0s. So 1 plus 0 is 1. 1 plus 1 is 2, but 2 doesn't exist. So that's a 1, 0. 1 plus 1 is a 3, but 3 doesn't exist. So that's a 1, 1. Base 2.
Because it's a 0, you just use it.
Hmm?
At 0, you want to just drop it. Oh, it becomes a 1 there. Okay.
Wait, so 1, 1, so 2 becomes a 0, 1,
Yes.
and then 3 becomes a 1, 1.
Yep.
And then what would 4 equal?
So if we count in binary, we have 0, 1, and then next would come 2, but 2 doesn't exist, so we go 1, 0. And then we go 1, 1, and then we go 1, 0, 0. We bring in the next place. And then we can add a 1 to the end of that. We can't add a 1 to the end of that, so we have to carry up. But we can add a 1 to the end of that. We can't add any more 1s there, so now we get a new place. And then we can add a 1 to that. We can't add a 1 to that, so we have to bump it up. And so on and so forth. Okay? So that's how we count in binary. We just keep on bumping it up. whenever we need to. You add a 1 when you can add a 1. If you can't add a 1, you bump it up. The next one, to add in base 16, you might want to create a list of what our numbers are in 16. Okay, so through 9 is just fine, but then once we hit 10, we call 10 A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. That's as high as we can go on base 16. So when I write it out, I'm going to write 135, and then in parentheses, instead of writing an E, I'm going to write a 14, but I'm going to put it in parentheses so I know that's one thing together. Okay, so I don't think it's a 1 and then a 4. I know that that's a 14 altogether. So then I have a 2, a 1, and a C, which is a 12. So now, when we add that up, we get 26. Okay, so I'm just going to write this little 26 here so I know what I'm working with. But 26 doesn't exist in base 16 because it's bigger than 15. You can only count up to 15. So we've got 1/16 that we can carry over. So we're going to carry over a 16. And how much is left over after I carry over a 16? 10, which is A. Okay? So just like in our normal arithmetic system, base 10 that we're used to, if we add up, we would carry over how many 10s we have. If we're ending up with something bigger than 9, we carry over how many 10s do we have. If we're working base 16, we carry over how many 16s do we have. At 1/16 and 10 leftovers. And 10 is the same as A. So now that 1 that we carried over wasn't really a 1, it was really a 10, right? Well, never mind. So, no, sorry, just leave it as a 1. It's in that place, so that's fine. So then we've got 7, 5, and 1. And so 16 down there. Yes?
What if you add together numbers and it equals 16? Is that
Then that's a 1/0. You carry over 16 and there's nothing left over.
right? Okay.
Okay? Questions on adding?
Wait, so you said if we have an extra 16, then it just becomes a 1/0?
If we added this and it wasn't 26, it was just 16,
Yeah.
then it would be a 1/0.
Okay.
So this was like a 110,
Right.
but 10 is A.
Okay.
Okay. Right, so subtracting. Subtracting is like our normal number system, except we're going to have to borrow. So if we can subtract, and that's not a problem. So 4 minus 3 is 1. But I can't do 2 minus 4, so we need to borrow. So when we borrow in our number system, we borrow 10, because our number system is based on 10s. But this problem is based on 5s. So when I borrow from this 4, it's going to become a 3, but that next number is not going to become a 12.
Could be a 7.
It's going to be a 7, because I'm borrowing 5 from the place before. So we borrow 10s because our number system is based on 10. In this number system based on 5s, we borrow 5 from it. So it becomes a 7. So 7 minus 4 is 3. 3 minus 1 is 2. And we're on base 5. Questions on that one? We have a couple more subtraction examples, but I have to scroll. Are there questions on this subtraction one? All right, so this one's in base 8. So So I can't do 2 minus 6, so I have to borrow. So the 3 is going to become a 2. And from it, we're in base 8, so I'm going to borrow 8, so the 2 becomes a 10. So 10 minus 6 is 4. I can't do 2 minus 5, so I have to borrow from the 6. I'm borrowing 8, so that's going to become a 10. Base 8. Okay, so now we have our letters again, so I'm going to make our little chart. Since mine's gone, I need to make it again, but you might still have it from before. Okay, so again, I wrote them with letters here. What you might want to do is instead put its number, but put it in parentheses so you know that A is a 10 altogether, B is an 11, E is a 14. Okay, so I'm going to do 11 minus 4. That's fine, I can do that as 7. 10 minus 14 I can't do. So from the 7 I need to borrow. It becomes a 6. And what does the 10 become?
26.
A 26, because we're in base 16, so we're borrowing 16 from the place before. So 10 becomes 26. 26 minus 14 is a 12, which we can call C. And 6 minus 3 is 3. So 3C7 is our answer. Questions? Multiplying. We're going to multiply the same way that we do in our number system, but again, if we end up with a number that's too big, we're going to have to think about it like the addition problems and kind of carry on over. So multiply 4 times 3 and I get 12. But 12 is bigger than 5, right? So to turn a 12 into a base 5, I'm thinking here, through my nose a second. No, okay, so we can just write it as a 12 because the 2 is still okay. 3 times 1, 3, add 1 more is 4, it's okay. Nope, you know what, I feel like I'm doing this wrong. Let me double think through my notes here again.
Well, because how do you?
Yes, I am doing it wrong, hold on, okay. Because 12 doesn't exist, so, okay. I wrote my notes wrong, so I was second guessing myself, but I know I'm doing it right now. Okay, so 12 is too big, right? That doesn't exist. So what we need to think about is carrying. And when we think about carrying, we have to think of how many of that base are there in our number. So the number we're thinking about right now is 12. How many 5s are there in 12?
2.
2. So we have to carry a 2. And how many's left over after that?
10.
2.
2. Okay, so it makes a 10, and then there's 2 left over from that. So that's how we figure out our carrying. So we got a 12. Okay, there's 2 5s in there, so we carry over a 2, 2 left over. So now I do a 3 times 1 is 3, plus 2 is 5, but that's too big.
So
How many 5s are there?
carry
A 1 with a 0 left over. 3 times 3 is 9, plus the 1 is 10, that's too big. 2 5s with 0 1s. Okay.
I always learn how to multiply lattice way,
Oh.
so I've never learned how to multiply this way.
I would have to
Is it pretty
think
easy?
about how to draw this in the lattice. I'm sure we could do it. Because the lattice is essentially the same thing. I would just have to think about where exactly each number would go.
Yeah.
But in this way, what we're doing is we're just doing the first thing by the top row. So 3 by the 4, 3 by the 1, 3 by the 3.
Okay.
And adding our carries in.
Alright.
So you put the 1 over, but there's still a 0.
And then
for the, like,
we're going to do the 2.
it's 2 digits.
I'm going to erase my carries because I don't need those anymore. And so now I'm going to do the 2 by the 4, which is 8. But 8 is too big. How many 5s are in 8? 1 with a 3 left over. And remember in multiplication, each number as we bump it over, it lines up. So when we were multiplying the 3 through, we lined up under the 3 to start. Now that we're multiplying the 2 through, we're going to line up under the 2 to start.
Do we put a 0 there? Or?
You can. It doesn't matter. It is a 0, but you don't have to write it in.
Wait, how did you get 3?
2 times 4 is 8, which is 1 5 with a 3 left over. So then we do 2 times 1. 2 plus the 1 is 3. That's okay. We don't have to carry that. And then 2 times the 3 is 6, which is too big. So that's 1 5 with a 1 left over. Then we add those up, but again, carrying if we need to carry here, but in this case, it doesn't look like we do. Don't put any commas in, like how we normally do with like our thousands and stuff. We put commas in. That's something that's like a number convention for when we're working a base 10. It doesn't really exist in other bases.
Okay.
All right, I'm gonna write a little bit smaller. Can't too much room problem.
I think I did it right. The ones
So
that
much
you
easier.
can't get bigger than one, so it's just
Right. So you know it has to be a 1 or a 0.
yeah. See if I did it right.
So 1 times 1 is 1. 1 times 1 is 1.
You're telling me.
1 times 0 is 0. 1 times 1 is 1. So we just get that first number over again, because we're multiplying by a 1. Then I multiply by the other 1. 1, 1, 0, 1. We get it over again, but it's bumped over a spot. Now we add, we have to be careful, because we can't get bigger than a 1. So here we get a 1, but a 1 plus 1, that's a 2. We can't do a 2,
0, 1.
so we got a 1 with a 0. Can't get a 2, so we got a 1 and a 0. Can't get a 2, so we got a 1 and a 0. Can't get a 2, so we got a 1 and a 0.
Did it right.
Because you're
Base
carrying over all
2.
those.
Because we're carrying on over each time, yeah.
Will you say it?
I said blue. I said blue.
All right. So that's our lesson for today. We're not going to talk about dividing. So we're just going to learn adding, subtracting, and multiplying in different base systems. And this will be the last lesson that is covered on Wednesday's quiz.
5 times 30.
Then like, you go to box.
No, I do one.